we use Jaeger. Actually, we use Jaeger through Istio. I think that might be a little bit outdated. I don't know if Jaeger's still around. And that helps you trace RPC calls across microservices. You still have to propagate some information through the headers about the span ID in order for it to actually work. There's systems like Istio and other service mesh that allow you to do that more easily. But then when you get to the point of tracing long-running processes, especially processes that go through a message bus, getting an end-to-end picture of what's going on in my order that takes several hours to fulfill is very, very difficult on a per-order basis. You can kind of understand what percentage of requests are succeeding on a certain server and what percentage of requests are failing, but you can't really trace a one specific order across its end-to-end life cycle of the process. By the way, here's a screenshot of Kiali. This is from their documentation. Basically, you see all the services in your mesh and you see what makes a request to what, which kind of helps debug this architecture a little bit, but it doesn't give you the full picture. This is one of the motivating problems which caused me to start LittleHorse, which is, yes, it's a competitor to Temporal. We're not going to talk about Temporal because we're keeping today focused on observability. I think my dad liked to go very, very hard after larger competitors, and I'm trying not to follow in his footsteps in that regard. I don't know if you've heard about him and Microsoft. They had fun together. So LittleHorse is a workflow engine that coordinates interactions between microservices. And the general idea here is instead of having a spaghetti system where everything is kind of an emergent behavior like a neural network, where the behavior of your system hopefully comes out to be correct, you define what should happen in one central location that is horizontally scalable, fault tolerant, and let that system organize what happens and ensure that everything completes completes to satisfaction. So, what observability we're focusing on today, there's a couple things. There's application performance, how long are requests taking to be processed, where's the bottleneck, debugging. So for example, a customer says, hey, my credit card got charged, but I never got the package shipped to me. What's going on with that? Or the DMV recently, I requested a new driver's license and it didn't come, so I had to fly with a passport and a piece of paper today. So, and then the last one is business insight, but we don't have time for that today. That's a completely different type of metrics, which is, for example, which sales agent or which call center agent tends to have the highest conversion rate. A workflow engine can help you solve that, and we're working on that at LittleHorse, but it's not ready yet, and we also don't have time to cover it today. So now, before I talk about how LittleHorse and a workflow engine can solve observability, we should define what workflow is. Now, LittleHorse obviously isn't the only workflow engine. In my opinion, it's the best, but this applies to all workflow engines that you can use for microservice orchestration. So this doesn't actually apply, the first part doesn't apply to temporal or restate, but generally a workflow engine, you define a template or a workflow specification that is a series of tasks that need to be executed in a certain order, conditioned on certain variables and inputs and certain events that happen outside of the workflow context. Then you define a series of task workers which execute actual tasks, and they pull a task queue and wait for the workflow engine to do stuff. And then you run a workflow, and the workflow engine sends work out to the workers at the appropriate time, and all sorts of error handling, observability, and change management is handled inside the workflow engine itself, rather than all sorts of manual dead letter queues, timeouts, retries, and all that other infrastructure that you have to build on your own. So I think at this point, let's go into a demo. Here's a disclaimer. I'm going to be showing a prototype that has been sitting since October last year. So this is not live real code. It is live real code, but it's not released. And we have engineers who are much better than me working on a proper version of this, and it should be ready to be released in the 1.0 release coming up in 3 or 4 weeks. So it will be in production soon. This is an old version of it from October, but that shouldn't really affect anything. So we're going to talk about online checkout, and we're going to do a simplified version just to demonstrate some concepts. So first we want to charge a credit card, and then we want to ship the item to the customer. Looks like the workflow would look like this. You charge a credit card, that's done by the payment service, and then the workflow moves on to another business context, which is the shipping or inventory service, which actually prints the shipping labels and ships the item. So the network topology, this is the workflow topology, the business process. The network topology in LittleHorse would look like this. You have a payment service, which is a task worker connected to LittleHorse, and you have a shipping service, which is also connected to LittleHorse. Now these services don't actually have to talk to each other, and that's way different from the spaghetti architecture picture which I showed earlier. They just talk to one thing, which is LittleHorse, the workflow engine, or it could be Conductor, could be Commanda CB, could be Orkeys, and that workflow engine will tell these services when they need to do what they're supposed to do. Okay, at this point, let's go into a live demo. Here is the LittleHorse dashboard. We have defined a couple tasks, but we haven't yet defined a workflow. Here's the code for a workflow of what we're gonna do. We first define a couple input variables. The first one is the item SKU, which is the name of the item that we're going to buy, and then the user ID is the person who's requesting it. We have a couple internal variables used for searching and observability. For example, status, I'll show you that in a second, how that helps with observability. And then what we do is we execute the charge payment task first, then we save some information in some variables, and then the next thing we do is we ship the item. So let's go back here. I think I had some notes. Okay, so what do we want to figure out here? We want to figure out what is the bottleneck, for example, if there's something being slow, what is talking to what, and why did something crash? That's what we're going to be focusing on right now. So first thing I need to do, now that I've started the task workers right here, we have the shipping service here and the payment service right there. I need to register the workflow specification. I'm going to do that right now, as soon as Java compiles. I love Java with all my heart, but it takes forever to compile. And please don't tell my dad I told him I like Java. I don't want him to get too happy about that. Okay, so here's the workflow specification in LittleHorse dashboard. As I said earlier, in workflow driven microservices, you define a workflow template and then you run it. So here's the template. It came from that code I just showed you about 30 seconds ago. We see there's two tasks that we execute and there's a couple variables that we defined. That workflow is actually, well, it's not there. I'll show you the workflow right now. The workflow, the code that I showed you compiled into this big massive protobuf, which is printed out as a JSON, and it defines the graph of what happens in what order. So just to show you how everything works, let's run a workflow. I'm going to say the user ID is Colt, and the item I'm going to buy is Lightsaber. So we can see here that the payment service charged Colt for a Lightsaber. Transaction ID is this. And over here on the shipping service, we saw that the shipping service shipped a Lightsaber to me because, you know, I want to be a Jedi. Unfortunately, that's not a career path that's available to me. So let's go over here. And look at the workflow, and we can see that we can see the value of all the variables in this workflow. We can see that it is done. Here's the transaction ID. We can see the output of the tasks, the input to it, so on and so forth. But you know, the happy path is never really interesting. So let's go back over here. Now Obi-Wan is asking for a lightsaber because if you paid attention in the Phantom Menace, you'll remember that Obi-Wan lost his lightsaber in the fight to Darth Maul. So Obi-Wan is going to ask for a lightsaber. Remember that when I asked for the lightsaber, it went very, very quick, right? So we run the workflow. Oh, wait, that didn't work. Oh, sorry, wrong Obi-Wan. Okay, Obi-Wan asked for a lightsaber. And what's happening? Why is it taking so long? We have no idea why Obi-Wan's lightsaber hasn't arrived. Oh, finally it just arrived. Okay, so let's look for Obi-Wan's workflow, right? Obi-Wan complained that it took forever for his lightsaber to come, and now we need to observe what's going on. So now we need to figure out what the transaction ID is. We can search for the workflow, and the user ID that we're looking for is Obi-Wan. And we see here's the workflow ID. So let's go look at this workflow in our dashboard. I'm acting like the customer service person. So here's our workflow, and we see that it is Obi-Wan's workflow. The status is done. And let's look at this charge payment task. So we see that the task was arrived at, this is probably too small for you guys to see. The task was arrived at 7 o'clock and 42 seconds, and it finished at 7 o'clock and 47 seconds. Huh, that's interesting. If we look at the other one, it was instantaneous. So what we can do is go look at the code, and you know, for the purposes of the demo, I said if the user ID is Obi-Wan, we're going to sleep for 5 seconds. But anyways, at least at that point, you have the ability to look at what is taking so long in the end-to-end process across multiple different microservices for one specific transaction. Whereas with sample tracing, if you're using Jaeger or Zipkin or something like that, you just kind of get statistical pictures of the big thing, but if you have one angry customer, you can't actually figure out why that one customer is angry. All right, so Gwen is, I don't know if you're a Star Wars fan or not, but I know Gwen is a great engineer, so Gwen might want to buy something like a GPU, right?
GPU would be good.
Okay, Gwen wants a GPU. Okay, so the user ID is going to be Gwen, and the item SKU is going to be NVIDIA. It's going to be NVIDIA H100. All right, so let's look at this workflow. This workflow, well actually, let's look for workflow. Let's look at this workflow right here. Go to the dashboard. Oh, that's not the dashboard. Go here. We can see the workflow is not done. Why not? Oh, there was a problem. The item is out of stock. Apparently there's no apparently there's no GPUs left, right? The interesting thing here is, we now have, on a per business transaction level, we can search for Gwen's workflow. I can show you this exactly. So Gwen calls and she's angry that she didn't get her GPU. So search for workflows, user ID, Gwen. We find this workflow, go to the dashboard, and then we figure out exactly what happened, that the workflow is out of stock, right? So now I go back to the drawing board and my product manager says, hey Colt, it's not okay to just drop workflows like that. You need to actually issue a refund because Gwen wants her money back. Right, so now we're going to do some live coding. Actually, let's go back and look at PowerPoint for a second. I'm an engineer, so I hate PowerPoint, but we're going to do it anyways. If we want to look at, I'm showing you a simplified version of this picture in the demo, but there's a payment service and then a shipping service, so if shipping fails, you need to roll back the payment, right? So you have a bunch of bidirectional communication, you have strong coupling between these microservices, you probably have logic in the shipping service that refers directly to the word payment service and vice versa. And I've worked on a system like this. I'm not smart enough to do that, so I decided to build LittleHorse because I'm not smart enough to work on problems that hard. So I'm going to show you something that I'm capable of understanding, which is this, what we want to do right here is if we have a problem in shipping, what we want to do is we want to issue a refund so that Gwen's not mad at me for taking her money and not actually giving her the GPU, right? So what we want to do is we're going to set the status of the workflow to failed. So if we want to search for failed workflows in the theme of observability, we have it in the variable right there. You can find anything that's failed. And then we're going to issue a refund. So let's go back to here. We're going to watch the payment worker right here. And we're going to, first thing we're going to do is we're going to update the workflow specification. And notice that these jobs right here, the workers are running the entire time and they're not being changed at all. I don't have to redeploy either the payment worker or the shipping worker. All I'm going to do is I'm going to update the workflow. Gradle, run, actually. Okay. Once Java compiles again. All right, that wasn't too bad. So let's go back here. And now let's go to the new version of the workflow. Wait, what happened? Oh, did I forget to save it? I forgot to save the file, sorry.
Java compiling fast might have been a hit.
Okay, sorry about that. My dad told me today if I'm speaking to people, I can't have a mistake in a live demo, so I apologize. Don't tell him about this. I hope it's not being recorded. So, anyways. Here we are. Here's the workflow. Now we see there's this little icon on this thing saying that there's an exception handler. So if we look at the workflow, there's actually two different threads in this workflow. There's the entry point thread, and then there's the exception handler thread. And this thread is this thread is quite simple. All it does is it issues a refund. This, as I told you, is the older version of LittleHorse. Because I was going to show you some stuff with metrics. Turns out we probably won't have time. But there are two threads in this workflow. If I get the workflow spec, we can see that this specification right here is the exception handler thread and has one task which issues a refund, right? So watch here, this is the task worker that charges the credit card. Let's run Gwen's workflow again. We can see that Gwen was charged and then she was immediately refunded. So now she should be happy, right? Okay, so let's take a look back at one more thing I wanted to show you. Go back to the old workflow. Or is it working here? Let's see. I guess not. No, this is too old of a version. Okay, so let's look at some stuff that's coming up next, right? So we've seen now we can identify bottlenecks in a specific task, in a specific workflow, a specific business transaction. We can see what talks to what. It's very simple because everything lives in a workflow specification. You can easily figure out why something crashed, and it's very easy to implement error handling logic. And all of this is compatible with AWS, so this can all run on AWS and make Bill a lot of money and keep Jeff Bezos happy. In the spirit of SaaS, one thing that's coming up is we want to make the metrics visualization a lot better. So right now, if there's a lot of all the data is there in LittleHorse. What are the average and max and P99 latencies of tasks and workflows? Visualizations aren't quite there, especially not on the old one. That's coming up very, very soon. We also want to get some sort of business level insight. So for example, you want to aggregate events at the business level rather than just the technical level. So a business level event might be new customer joined. A technical level event would be task completed or task failed. Then next thing we want to do is we're building a SaaS cloud service, which is coming up soon. Also, thanks for your time. There's t-shirts in the back, very limited quantity. Would recommend you if you take them, but don't want to cause a stampede. So be careful with that. Well, thanks for your time, guys. If you have any questions, I'm happy to take some.
Why the name LittleHorse?
Well, someone already figured it out. This is somewhat secret, but Colt, it means little horse. The official answer, if anyone asks you, is horses are fast and agile. And if they're little, they're super agile. That's the official answer. The real answer is I was playing pond hockey, and I had to choose a name to put on the back of my jersey, and it couldn't be my real name, so I put LittleHorse. And then the jersey came, and then 2 days later, I started the company. And the jersey was cool, so I named it after the jersey.
Is that like A/B testing for different stories? Because we can vote for which story.
Saying it's named after myself makes me sound like a narcissist, so I prefer not to say that.
So when you have a simple kind of path like you showed, like
Yes.
this kind of thing happens, and therefore you immediately revert the payment. That's one thing.
Yeah.
But there's a whole bunch of business logic that might have to go into that. Like for instance, maybe the customer says, you know what, I'll wait, right?
Mm-hmm.
So have you thought about like how you're going to build in those kinds of logic gates? All the different processes that could happen.
I could do a live demo, but I don't have 10 minutes to write the code.
Right. Okay.
Yes, you can.
It's
So
extensible programming.
it is extensible. So if you look at the code again, we tried to make it very similar to the temporal SDK. The temporal SDK is fantastic. There's other things about temporal that are less fantastic, but the SDK is good. So there is conditional branching, there's multiple threading, there's user tasks, which temporal does not have, where you can wait for the input from a user and assign these tasks to actual people or departments and stuff like that. So yes, you can have a user task that sends a notification to the customer and wait for them to say, do you want to wait or not? And depending on if they want to wait, they either get a refund or we wait until an external event, which is a notification from the external world, comes in and says, oh, GPUs are back in stock.
Right.
So it can be very extensible.
And so then my follow-up to that is that, doing one transaction per 15 seconds, you can do as a human demo. Now to scale this to maybe 100,000 to 1 million, operations per second, what's your scalability distributed architecture then?
Well, we owe a lot of that to Gwen, because I read her book, and then the architecture came out of that book. But it is actually built on top of, I don't want to say this because it's going to confuse people, but it is built on Kafka internally. We don't expose Kafka at all. The Kafka API is not at all exposed to our customers, but LittleHorse is horizontally scalable, and our storage layer is Kafka.
Okay.
So for some numbers, benchmarking, we're able to do, on one partition of Kafka, we can do 1,100 tasks per second of scheduling. And obviously you can have hundreds of partitions, so that gives you hundreds of thousands of tasks per second. And latencies, about, depending on how far apart your data centers are, it's about 15 to 30 milliseconds between one task finishing and the next one starting, compared to, I'm not going to name them, 150 to 250. So it's a little bit faster.
That's great, thank you.
All right. I know we're on a tight schedule, so I really want to get about the org presentation, because actually when we build the SaaS cloud service, we're going to be using org for the usage-based part of the building. So very excited for that.
Thanks, Colt.